So first we have here multiplying rational expressions, and in multiplying rational expressions, they note that the key is simply to multiply the numerator and the denominator respectively. But before doing that, the usual trick is to first factor out what you can factor out and maybe cancel out or divide out factors to simplify the expression immediately. And let's do that. So we have here for the first fraction, take note that the numerator can be factored out into 3 times a minus b, and then the denominator can be factored out into c times c plus 3d. That is because in the denominator we have a common factor of c and then c here. So that one is already factored, and then we multiply this. Again, factor out. This time the second rational expression or fraction. So in the numerator, we have a common factor of 2 and d. That is 2 and d because in here, take note that d squared, obviously it has a d, and 6 when you divide that by 2, that would be 3, or that is 2 times 3. So we'll be left here with just c, and then on the other side we have here 3d. If you're unsure if the factoring is correct, my tip here is to just simply combine them, or by that I mean multiply this to this expression and see if it matches out here. Okay, so then lastly, for the denominator of the second fraction, we'll have here a common factor of c. So we'll be left with a minus b. There you go. And from here, observe that there are certain factors that will cancel out. In particular, a minus b here will cancel out, and then c plus 3d here will cancel out. So we'll be left here with just simply multiplying the numerator and denominator. So we'll have here 3 times 2d, that will be 6d, and the denominator will be c squared, right? And that is basically the final answer. Let's just fix this one. Okay, so this one goes here, this one goes here. Maybe we can move it out here. And yeah, this is the final answer. So I hope that first item was clear. Okay, so next one we have here dividing rational expressions. For this one, basically we apply the same idea in multiplying rational expressions, but there is a certain catch out here because we have here division. The rule in dividing rational expressions is that what you do is you convert this to multiplication and then get the reciprocal of this one. So with that, we'll have here x cubed minus 8 times x squared minus 6x plus 8. Again, convert division to multiplication. And then get the reciprocal of the second expression, or by that I mean switch out the places of this one and this one. So we'll have here x minus 4 and then 3x cubed plus 6x squared plus 12x. And then from here, apply the same game a while ago, and that is factoring out the numerator and denominator. So for the first one in here, take note that 8 here can be written as 2 cubed. So basically, we have a difference of 2 cubes. And just recall that when we have here, a cubed minus b cubed, this can be factored out into a minus b times, a squared plus ab plus b squared, right? So applying that out here, I think we need a longer line. Applying that out here, we will have here x minus 2 times x squared plus 2x plus 4. There you go. And then for the denominator, this is a quadratic trinomial. And recall that when factoring this one, what we do is we think of two numbers that when we multiply, we get this. And when we add, we get this. This one is equal to negative 2 times negative 4. And when you add that, negative 2 plus negative 4, we get negative 6. That one is quite small, but let's just write out the factored form out here. So we have here again x minus 2 and x minus 4. Again, when you multiply this negative 2 and negative 4, you get 8. When you add these two, you get negative 6. So for the numerator, first x minus 4, take note that we can't factor out that anymore since that one is linear already. And then for the denominator, take note that we have a common factor here of 3 in each term, as well as x in each term. So if we factor that one out, we'll be left with x squared for the first one, right? Then for the next one, we have here 2x. And then for the last one, we have here 4. Take note that a bunch of factors here will cancel. The obvious one, first, x minus 2 will cancel out here. And then we have here x squared plus 2x and x squared plus 2x plus 4. And then lastly, we have here x minus 4 and x minus 4. So actually, we'll just be left with, in the numerator, we'll just everything cancel out. That means we'll be left with 1. Not 0, and then in the denominator we'll be left out with 3x out here. Okay, so to write that one out, we'll be left with 1 in the numerator and then 3x in the denominator. And this one is already in the factored form or the simplified form. There, let's just oopsies. Sorry, I'm kind of perfectionist out here. Okay, I think that's better. So that's it for the first two items. That is multiplying rational expressions and dividing it. Now let's go on to subtracting rational expressions. So in here, take note that when we have one fraction here and one fraction here, the key is just to simply apply the butterfly method. By that I mean what we do here is we multiply this one and the expression there, let's say a would go here, and then next thing we do is we multiply this one here and the expression there will be this one, then copy the operation, which is subtraction in this case, and this one will be all over the denominator, which is multiplication of the denominator, which is this one. So we'll have here that one, and it will look something like this. So a minus b all over c. So forgive my drawing, it doesn't really look like a butterfly anymore. Okay, so going back, let's apply that one. So again, we multiply this here, this thing here, and we'll have here x plus 1 times y. Let's copy the operation immediately, and that is subtraction. And then we multiply these two, so we'll be having x times y plus 1, and in the denominator we'll simply multiply this one, and we'll be left with xy out here. And then let's just simplify this one. So in the numerator, take note that when we multiply this one, so basically you distribute y in both terms, so we'll be having xy plus y, and then the next one we'll have here distribute x out here, or maybe to be specific, distribute negative x out here. So we'll have here minus xy and minus x. And take note here that we have xy minus xy, so that would just simply be 0, and then we'll be left with y minus x all over xy. So writing that one down, we have here y minus x all over xy. And that is already the simplified form of this. Damn, I have to correct myself multiple times. Okay, there. Yeah. So an alternative solution here, if in case you didn't notice, you can actually, okay, let's just write it out here. So alternative. Take note that x plus 1 over x can be written as 1 plus 1 over x. Well, basically, take note, if we have here a plus b all over c, we can write that as a over c plus b over c. So applying that same idea out here, we'll be obtaining this one, since x over x is just 1. Minus, for this second one, we apply the same trick. So we'll have here 1 plus 1 over y. And clearly, when you simplify this, you'll obtain the same thing out here. Just ones here will cancel. 1 over x minus 1 over y is simply this one. Okay, you can try that one out. But that's it for the third item. And then the fourth one, here, instead of just adding or subtracting two rational expressions, we have 3 this time. Common error here is applying the butterfly method twice. Apply it here, then upon obtaining the answer, apply it here. But that is quite long. What you can do instead is observe or find a way how to make the denominators here same. Or in other words, if these are numbers, what is the, I hope I say this correctly, the least common multiple? I think that is correct. Yeah, what is the least common multiple? Or how can you make the denominator the least common multiple? In this case, take note that if we multiply here, oops, wait, there's a dust. Okay, there was dust that came. Now going back in here, we can multiply this first one by a over a, the second one by b over b, and the last one by c over c. Take note that we can do this since a number or even a variable over the same one is simply just 1. The value doesn't really change. And upon doing that, notice that these denominators will all be equal to a, b, c. So we can combine these. So that's quite a lot. So let's illustrate that one out here. So the denominator will become ABC. And then for the first one here, again, we multiplied here a over a. So we'll have here a squared. For the second one, we multiplied here b over b. So this one will become b squared. And then for the last one here, we multiplied c over c. So we'll have minus c squared. And that's it for the answer for this one. Let's just fix this one. Write it much better. Yeah, so as you can see, it saved us quite a lot of time. There are certain things that I just did right out here, so I'll just put here an exclamation point. And then that's the answer for this problem. There you go. So we have here a difference of two rational expressions, and like a while ago, you can apply the butterfly method or apply the method we did above. And that is to get the LCM of these two. I prefer that one since that would minimize the things that we multiply and simplification. So applying that one here, take note that 2x minus 6 here is equal to 2 times x minus 3. And then for the second one, x squared minus 9 is a difference of 2 squares. So this one can be factored into x minus 3 and x plus 3. Okay, let's see. Do I have space? Yeah, I do have quite a lot of space. So let's write that one down. This one is 2 times x minus 3. Let's leave a certain space out here. And we have here 9 and x minus 3 times x plus 3. And then from here, take note that if our goal is to make the denominators equal or the same, what we need to multiply out here is clearly the missing one on the other, and that is x plus 3. So with that, we'll have here times x plus 3 x plus 3. And then for the second one, the missing part out here is 2. So we multiply here 2 over 2. There you go. And so that means that these two fractions will combine with a denominator of 2 times x minus 3 times x plus 3. And in the numerator, we have here, okay, we have some space, so we have here 3 times x plus 3 minus 9 times 2. Let's just fix this one. So as you can see, this saved us some trouble in multiplying more or higher degree stuff if we ever did the butterfly method. So simplifying, the numerator will have here 3x plus 9 minus 18. So let's just copy the denominator again. Yeah. And in here, take note that 9 minus 18 here would yield, actually let's go out here. 3x plus 9 minus 18 is equal to 3x minus 9. Or when factored, we'll have here 3 times x minus 3, right? Since I do lack space already, just take note that the x minus 3 here part will cancel out with this one. And so we'll be left with, in the numerator, we'll just be left with 3. In the denominator, we'll be left with 2 times x plus 3, or simply 2x plus 6. And this one is the final answer for this one. So yeah, it's still quite a lengthy process, but it's manageable, I would say. Okay, then 6.1, we have here a complex fraction. So now we arrived with a complex fraction, and to deal with this, the trick is simply to remove the complex fraction. And by that I mean, we multiply something out here in such a way that these denominators out here within the fraction would be removed. So what's a good candidate to multiply out here? Obviously, you can multiply x over x in the numerator and in the denominator. And if we do that, look at what will happen out here. So if we multiply x in the numerator, this one distributes here and here. So we'll be having here x squared minus 9 over x times x is simply 9. And if you apply the same game in the denominator, x here will multiply to 1 and then to 3 over x, so we'll be left with x minus 3. There. And then take note that x minus 9 is a difference of 2 squares. So that means it factors out into 2 factors. In particular, that is x minus 3 and then x plus 3. Oops. There you go. Yeah, and the denominator will be x minus 3. Then since we have a common factor here, we cancel out the x minus 3 and we'll actually be left with just x plus 3. So as you can see, a complex thing simplified to just a simple thing, and that is x plus 3. Okay, so last item out here, we have a more complex fraction, I would say. So again, if we apply the same trick from earlier, we simply just multiply here w plus 2 all over w plus 2. But a slight trick here is that I would want you to observe is that we can actually group this one. Okay, let me write that one down. We can view it as w minus 2 with a parenthesis. And when we do that one, take note that when we multiply w plus 2 out here, instead of multiplying it individually to w and 2, which is fine since you'll get the same result, it would be more nice if we multiply w plus 2 to this product, since we know that if we multiply the sum and difference of a binomial, we simply get the square of the first term minus the square of the last term, or the difference of two squares in reverse. So doing that, we'll have here w squared minus 4. And then if we multiply w plus 2 out here, the w plus 2 in the denominator will disappear and we'll be left with w minus 2. So in the denominator, we do the same, multiply this here, and we'll have here w squared plus 2w minus 3w plus 12. Okay, of course, things will still get messy out here, but let's simplify this one. Do we have space? Dang, I have tremendous space. So, does that mean that this one will be still long? I don't know. Let's simplify the numerator out here. We'll obtain w squared plus w minus 6. And then out here, if we distribute this one, we'll have w squared plus 2w minus 3w minus 12. Okay, so just a couple of things more. Okay, let's just simplify the denominator first. So in the numerator, we simply just have w squared plus w minus 6. And in the denominator, we'll be having w squared minus w minus 12. There. And from here, we just simply factor the numerator and denominator and hope that there will be things that we could cancel. Take note that we have here a quadratic trinomial. Oh, I hope I did this correctly. So take note that in the numerator, this factors out into w plus 3 and w minus 2. A quick check. So 3 times negative 2 will give us negative 6. If you add 3 and negative 2, you get 1, or simply the coefficient out here. And then for the denominator, we'll be having w plus 3 and w minus 4. And fortunately, we can cancel out a term out here, and that is w plus 3, which means that we'll be left with the answer of w minus 2 all over w minus 4. Can't cancel that anymore, so we conclude with this one. Not with that, with this. Oh, thankful that that one is correct. And so yeah, that ends the items for this part, rational expressions and complex fractions. So yeah, you can view this one. So this is what we have so far. And then these items out here. Yeah. So yeah, if you have any questions or concerns about this, or some constructive criticism about the videos, please make sure to let me know about that so we can improve further in the future videos. So in the next part, we'll be dealing with rational exponents and radicals, and finally with complex numbers. Thanks, and I guess have a great day.